Let's go to this one, which I think you and I both seem to like, which is the Code and Dirty one. I think you wrote this last year.
Yeah.
And it's a bit of a response to clean code, not
Right.
specifically, but like there's this idea of like how you're supposed to write software. Of course, Bob Martin's Clean Code book, which is
Right.
highly regarded and both also and also hated kind of a piece of work. And you wrote Quick and Dirty, which is contrarian to a certain extent, but I also find myself nodding my head. So
Right.
talk me through some of the thoughts here on your coding style.
Well, Bob Martin and clean code is definitely a dominant idea. It's a dominant sort of ideology, I would call it, maybe
Yeah.
in coding. And there are aspects of it that I don't hate or that I don't disagree with entirely, anyways. But there are aspects of it that I don't agree with, and I definitely code very differently. And I've had a pretty successful programming career. And so I wanted to communicate, particularly to younger developers, like, don't be intimidated by these things. It's one thing I dislike, and I have, Bob and I have kind of gotten into it on Twitter a little bit, jokingly though. He's been a very good sport and like doesn't take it seriously. So I really appreciate that. We don't agree with one another, and we can make a joke out of it. So, but I really, I think there is what do I want to say? I think younger developers can be intimidated by these terms. Like clean code is one of these sort of like, how could you be in favor of dirty code? Like, how could you be
Right.
opposed to this? And then you look at the actual ideas and you're like, wait a second. Like,
Right.
there's the headline and then there's the actuality of it. And the headline, yeah, of course, everyone wants their code to be clean, but then the realities of the recommendations, I think, don't necessarily hold up. And so now that I've had some success as a programmer, one of the things I'm trying to do is to go out and say, like, look, guys, I do things pretty differently than most of these, particularly sort of the consulting oriented, clean code, agile, like that whole world. The way they say to do things, I do things pretty differently. And I've had a pretty successful career. And so that was the inspiration of this essay. And I think there were three sort of things that I went at. So I don't believe in short methods for the sake of being short. I think long methods are okay. And I don't unit test my code. Like I don't do TDD. I do test my code, but I don't necessarily do unit testing and sort of what I would call ideological approach of like always writing a test before you write any code. And then the last thing that I take issue with or that I sort of say, this is how I do things different, is I tend to write code with classes that are much denser and bigger than clean code advocates would recommend. And so I tend to mix concerns. I have classes that do more than one thing, which is something that clean code people would object to. So those are sort of the three things that I picked out in that essay to focus on. So, and I'm happy to go into each one individually.
Yeah, let's talk about big functions because I've definitely done it both ways. Early on in my career, like early on, you don't really have opinions because you don't know what's good or bad. You're just like, I need to make a thing, and so I'm going to try to make the thing. And so I was very open to advice. And I remember early on in the Ruby community, I took Sandy Metz's advice on many things. And one of the things she said, of course, she's very level setting in her ideas, but she'll say, follow the rules until you know better, and then break the rules all you want, as long as you know why you're breaking the rules. One of the rules that she had was short functions. And I think she even says like 5-line functions, like just give yourself 5 lines. And if it's more, just have another function and just do that for a while. And eventually you'll know why, and you'll know when not to, and you'll break that rule. But there's a rule. I think it was 5 lines, which in Ruby is very small because like 2 of them, like we're not using curly braces. So like 2 of them is the def and then the end. And so you're like, what, 3 lines? I tried to follow that rule for a while.
Yeah.
And I found it incredibly constraining. And eventually I broke out of it, but it always gave me this sense of like, if a thing starts to get too big, I start to at least think about a refactor. I may not do it. But I didn't really consider back then this idea of functions matching kind of function size matching kind of the importance of the code.
Yeah.
And I definitely realized it with classes. I mean, you have like your user class, for instance. You're like, you can go look at any app and see its user class or whatever it's functionally
massive.
To that. And you're like, you're like, okay, here's the app, or there's usually like 2 other classes that are like,
Right.
here's where the majority of the app is. I think that's good. I think
Yeah.
it's good to have this sort of like matching up, which I think is some of your point. But when you say
Yeah.
long functions or
Mhm.
big functions, are you talking like 10 lines, 20 lines, 500 lines, 2,000 lines? Like what are your thresholds?
I don't really have a threshold. I definitely will start feeling antsy when a function has more than say 100 lines of code in it.
Mm-hmm.
But if it's an important function and if there isn't reusability to be achieved by pulling the code out, I still won't refactor it just because it's too long. I try to make being too long not the reason I do things. If there's code reuse, then I'll do it. The reason for that is so you touched on it already. I think it's important functions should be big. Like important things in general should be large, and unimportant
Mm-hmm.
things should be small. And so when you go into a code base, if there's 100 5-line codes, it's kind of hard to get a handle on what is happening there, you know? And obviously it depends on exactly what style of code that is. Is it like a library, like a list thing, or is
Sure.
it like domain logic, or is it controller logic, or whatever? So it really depends on the what style of code that is. But I prefer to go into a code base and be like, okay, here's like the 5 functions that are really important for me to understand, and let's go through them and read them top to bottom, and not have to be navigating down 5 levels deep, and then coming back up and then going back down, doing that sort
Mm-hmm.
of tree walk that you have to do if you have too much decomposition in a code base. And I use IntelliJ and all the JetBrains products, and I'm good with navigation. So I can move around, but I still just find myself preferring just tell me what you're doing. Just show me
Right.
only like you do this, then you do this, then you do this, and fine. It doesn't all need to be factored out if there's no code reuse to be achieved with it. So I think
Okay.
that's important. I think another important observation, and this is a bit of wisdom in computer science, is that there's 2 hard problems, right? Cache invalidate or naming things, and cache invalidation and off by 1 errors. And
Right.
so naming things is one of the 2 hard things in computer science. And whenever you extract a function, you've got to name things. You're like
For sure.
committing to the parameters, the signature. Like if you accidentally make it public, someone else suddenly starts relying on it. There's a
Mm.
lot of danger in pulling code out into a separate method that I think is unacknowledged by people that act as if pulling code out to another function is just a free operation, or in fact will just make things better just because you did it. You have that name changes, you're sort of committing yourself to that particular bit of logic now because it's somewhere else, so it's harder to go and change. And there's just a lot of like things like that where you end up constraining yourself because you've committed to this sort of signature now, a name for this thing. And so I definitely, it's like I start to get itchy when a function's 100 lines of code, but
Mm-hmm.
I try to be disciplined and like, okay, if there's no code reuse to be found here, like I'm not going to pull it out just to pull it out. Maybe for testing, maybe, but then that gets to the testing thing where I tend to prefer end to end and what are sometimes called integration tests rather than unit tests of like functions. Like I don't like unit testing as much as I like those other styles of tests, and so
Uh-huh.
that I think sort of dovetails with my opinion on longer functions. There has been some academic work, some actual empirical work on this, believe it or not.
Okay.
And the empirical work that I've seen indicates that you actually, until I think it was like 200 lines of code, you actually end up with fewer bugs per line of code if you're willing to allow functions to get larger. Um, and then there was someone kind of like tried to fact check me with a more modern paper on it, and again that paper didn't show strong association with longer methods and bugs per function. So
Mm-hmm.
it doesn't seem like there's much empirical evidence that long functions are bad. It's mostly just an assertion based on what, as far as I can tell, are aesthetics.
Right. So here's something that I will do sometimes, and I wonder if you would do it or not. Sounds like probably not. If code reuse is your indicator for extraction,
Mm-hmm.
is let's say I have a module that it does one major thing, and it's kind of complicated. Like let's just call it like a checkout of an e-commerce. Like at checkout
Yeah.
time, there's like 5 or 6 things that you have to do,
Right.
and so like there's your function, whatever, call it checkout, and then it's gonna have 5 or 6 steps, and each of those steps, like I might even like leave myself a comment, like here's my steps, 1, 2, 3, 4,
Mhm.
5, and I'll describe them. And then I will either have to decide, do I just code those up right here? Or is each one of those the name of a subroutine, and I
Mhm.
code them up in separate routines. I've done it both ways. I honestly don't have like a strong opinion on it being better or worse, but will you just like code all 5 steps right there in the function most likely, unless there's code reuse?
Yeah.
Or would you would?
I'd probably put all 5 right there, maybe with comments indicating step 1, step 2, step 3, step 4, step 5.
Mm-hmm.
And in particular, what I would look for is there shared state between those things? Because if there's like more than one thing that's kind of crossing boundaries for those 5 steps,
Yeah.
now extracting that out like can get dangerous because you have to encapsulate that state, and are there callbacks or like some crazy,
Right.
you don't want some crazy callbacks. So like, but I would be inclined to write it the linear way with just ifs and loops, and then if that proves to be unstable or I need to test them individually or something like that, then maybe I would extract them at that point. But I definitely wouldn't extract them. I would write it for sure the first time, just a straight line code.
Straight through.
And then if that wasn't good enough for whatever reason, then I would start, and I would look for opportunities to like pull out utility methods if I see it doing kind of the
Right.
same thing in a couple places. But I wouldn't feel it necessary to structure something where it is like like that's an important thing for someone to see, that there's like 5 things going on here and sort of in a linear set of steps. And so I wouldn't try and hide that from them too much.
Right. But for instance, if step 2 was calculate shipping,
Mm-hmm.
well, there might be some other time you're going to calculate shipping. You probably wait until you're actually doing it elsewhere. Then you might pull that one out,
Yep.
call it from there, and then also call it from somewhere else. That makes a lot of
Yep.
sense to me.
Yeah. That's the way I would do it.
I do like unit tests, not for any other reason, but they're easier to write and they're faster to run. And so I feel more productive. Like integration tests are like such a drag because you have to do everything. And I know that's like what the app does.
Yep.
But it makes me not like them. They're slow, they're expensive. A lot of times they include some sort of a runner, which may have to fire up Chromium or something.
Right. Yeah, so the language here is always difficult because, like, what is a unit test? And this is one thing that infuriates me whenever I'm dealing with people online. Like, test advocates are often like, they'll argue definitions rather than concepts. It's like, well, that's not a unit. That's not a real unit. It's like, okay,
Right.
Like, I'm not talking about what a
useful.
Unit.
Yeah.
So to me, a unit test is a test that like you have one function that maybe doesn't call any other parts of your system, or you mock those calls out. That's a very common practice in unit testing. And so you're really just testing the logic in one method at a time. Whereas what I call an integration test is anything sort of higher level than that. And I think even testing the public API of a class, for example, is not unit testing necessarily, because the internals of that class might be pretty sophisticated, may hit a database, may do like whatever.
Right.
And so that's the level that I like to work at. So my criticism of unit tests is that they often test implementation details and they're not high level enough. And so, yes, setting up a good integration test suite can be some work and can take some time to build out all the utilities that you need and so forth. Often you have to build data objects or whatever. But my experience is that those tests tend to survive much longer because they express higher level truths about your code base. Whereas unit tests tend to express more ephemeral, like this is true for now, but then if I go into a refactor, then they're all going to break. And the real hard thing about that, in my opinion, and one reason to maybe be a little bit more careful with your unit tests is that when you get a large unit test suite and you've got thousands of tests, that size has its own quality of like leaning on you. Like you can't do a big refactor because you're going to break all these tests. And which of these tests actually, like which of these tests that are broken are tests that are broken because we did the refactor and we want them to break? Like, and which are tests that we actually broke something important? And that can be really hard to tell when you get, like I've worked at companies with like, 50,000 tests that take 10 minutes to run. And it's like, I'm not going to refactor anything because if I try and clean it up, it's just all this stuff is going to break. And I'm going to spend 4 weeks trying to figure out what is really broken and what just went away or whatever. And so that again, I think that's one reason to try to get the assertions that you make about your system up to higher levels, sort of away from the details of like the implementation, which unit testing, and again, again, you can argue about language and all the rest of it, but I think unit tests tend to test implementation details too much. So,
Sure.
but I acknowledge 100% what you said, which is that the higher level the tests get, the harder they can be to run. They take longer to run because you got to set up maybe some state and so forth. And then when you get to end-to-end tests, like you're talking about browser tests, like it's so far away from the code that like, okay, did this test break because a label changed or an ID of an element changed,
Right.
or did like something actually break down in the mug? And so I love end-to-end tests, but I think you have to be really careful there too, for exactly that reason. You need to keep that end-to-end test suite relatively small. Otherwise, people just start ignoring it because it breaks all the time and no one can figure out what's going on with it. And that's why, again, I really focus on what I would call integration tests, for lack of a better term, just like
Sure.
not unit tests and not end-to-end tests. So what are those? I don't know, integration tests, those sort of
Right. Somewhere in the middle.
those in-betweeners.
Right.
Hopefully they can run fast enough that they're still not like incredibly painful. And then when something breaks, it's more obvious than in the end-to-end case. So things break less frequently than unit tests and more obviously than end-to-end tests. So
Yeah.
that's why I speak up for what I call integration tests, but I don't
Right.
know, for lack
Yeah,
of a
there's
better term.
certainly a give and take with a test suite where it's like on one hand, it's kind of an asset that you have
Mm-hmm.
because it gives you assurances that your software continues to operate the way
Yeah.
it was designed. Of course, with the asterisks in there that maybe you tested it wrong and stuff like that.
Right.
But on the other hand, if you value that asset too highly, now it's actually holding you back from making progress. And
Yep.
so in smaller code bases, especially ones where I'm the primary author, I have no problem either refactoring the tests right along the code or deleting the tests.
Mm-hmm.
Sometimes after I write the unit test, it's already done its job. I know the function works.
Mm-hmm.
Test can be gone. But
Right.
in large projects with multiple developers, you didn't write those tests in the first place. You don't know if that test is passing because you changed this interface in a way that makes sense, or if you actually broke something
Right.
unbeknownst to you. And so it becomes can become a hindrance to progress in that sense.
Yeah, and I think that's it. This is similar to the case with extracting functions. Like people act like adding a test is cost free or like always a net positive. Like there's no cost associated with it. And that's just not true. Like
Yeah.
extracting a method, there's a cost associated with that. Adding another test that like isn't gonna, even if it's testing correct behavior today, if it's super low level and testing like a particular implementation, like that can hold you back from changing that implementation. And people
Mm-hmm.
say, oh, well, you just refactor the test too. And that's fine to say, but as you point out, when you get into a big development, or even if you can't remember why you added the test, which I'm old now, so that happens. Like, what was this test even doing? I don't know.
Right.
Then it's not as easy to just delete tests as people say. So there are costs associated. I think that's one meta point I would make to anyone who's listening, and is particularly younger developers, is that all these things have costs associated with them. Like closures are another great example. I love closures. Like I love like doing data structure manipulation with sort of functional style maps and all that stuff. But closures can get super out of control and you can turn into a like callback hell like you have in JavaScript. And
Right.
so many of these tools that we have, it's just Aristotle again, right? Like there's like underuse and overuse, and then there's the golden mean, and figuring out what that golden mean is sort of wisdom in development. So I think anytime you get someone who's like X is the way, it's like, well,
Right.
okay, but like there's probably some trade-offs that are associated with that, and I like to talk about those trade-offs, and not present any particular tool or approach, or certainly the way I do things is like always unilaterally just the best way to do things.